Students, you are learning symmetry, reflection and rotation. In that you are learned about symmetry. You got the conception going through the previous video on symmetry. Now I will be talking to you before I take on your exercise, exercise 5, page number G 53. I will just discuss another aspect that is rotational symmetry. First I will cover rotational symmetry, then reflection, then rotation I will cover. See, rotational symmetry is what? See, I will tell you, on rotation, a body is there on rotation. If it takes a symmetrical position, that means whatever the position was there earlier, if it takes the same position, then it will become, that is considered as rotational symmetry. Take this pen. If suppose this is side A, this is point A, end A and end B. If you give a rotation just 180 degree, A point comes to B point and B point goes to A point. That is turning 180 degree. So on rotation it is become symmetrical. Again, from it was the original position. If you give completely 360 degree rotation, then it goes to its original position and it is symmetrical. So it can be symmetrical giving two rotation. One is 180 degree, another is 360 degree. So this is what I am going to talk about. See, children, I will take one line segment. Line segment has got this point of symmetry, and then it has it has one line of symmetry, isn't it? Line segment line segment can be symmetrical if you draw a line just vertically through the midpoint of the line segment, isn't it? Suppose line segment, this point is called A and this point is called B. If this A point goes to B point, that will be symmetrical, and then A point gives complete rotation and comes back to A point, will be symmetrical. So it will be 180 degree and 360 degree. Okay. So the line segment will have rotational symmetry order 2. Rotational symmetry order we say also. See, this is a particular side that is holy symbol, so speak. This actually you can't draw a line of symmetry on it. Can you draw? Is there any line of symmetry? If you draw through this, will this part be symmetrical to this? No. So it doesn't have line of symmetry, but it can have rotational symmetry. See how much when this A point comes to this, that means this arms comes to here, this particular part, this much rotation, isn't it? It will be symmetrical. If it comes this much rotation, it will be symmetrical. If original position from here, if it comes this much rotation, it will be symmetrical. And from here, if it gives complete rotation, it will be symmetrical. So it is, which order it will follow? It will follow rotational symmetry order for how? That if the minimum turn is x degree, total rotation is 360 degree, then order will be 360 degree by x. So how many terms? This will be 4. So if it is 4, then 360 by 4, which is equal to 90. 90 degree will be smallest term. See, first term will be 90 degree. Again 90 degree is 90 plus 90. So what are the order 4 will be in this case? So speak. It will be 90 degree, 180 degree, 270 degree and 360 degree. I hope it is understood to you for so speak. Could understand? Similarly, you see, if you have got the 3-bladed fan like, this all are, can you draw a line of symmetry? You can't draw a line of symmetry. See, think of, it will not be folded. So it has got a point of symmetry, but rotational symmetry will be following what? A will go to B, it will be symmetrical. A will come back to C, it will be symmetrical. A will go back to again A, it will be symmetrical. So it will follow order 3, and then 360 minimum term will be what? 360 divided by 3, that is 120 degree. Now 240 degree and 360 degree, isn't it? It will have like this. Now say about rhombus. It has got two lines of symmetry, no? Does parallelogram has a line of symmetry? No. It has got two lines of symmetry. What order will follow? It will follow. See, rhombus. If you are rhombus, you are turning to 180 degree, then it will be symmetrical. This G point go to B point will be symmetrical, and that time A point will become coming to C point, and then complete rotation that D point will comes to its original position that time. That means it will have order 2, that is 180 and 360. Moving on to any regular polygon, how will you find the rotational symmetry? See, regular pentagon I have taken. So it can have 5 axes of symmetry. 5 axes of symmetry. This point A goes to here. It will be. If it gives a rotation and goes to here, it will be symmetrical. Point A goes to C, it will be symmetrical. Point A goes to D, it will be symmetrical. Point A comes to E, it will be symmetrical. And point A comes back to its original position, A, it will be symmetrical. So it will have how many rotation? It will have 5 rotations. So all the regular polygon will have n side will have that many rotations. So that order it will follow. So it will minimum term will be what? 360 divided by 5. That many terms will be. So how much will be there? 5 7s are 35, and then 5 2s are 72 degree. So A comes to B, it will be 72 degree minimum term. I hope you have understood. Now see, I will tell you letter N I have taken. Letter N will not have any line of symmetry. Do we have? Letter N will not have. Letter S will not have. Letter F will not have line of symmetry. But letter N has got rotational symmetry. See, letter N, if you this position comes back to it, it will be symmetrical, and this position comes back to its original position, it will be symmetrical. So it will have order 2 180 degree and 360 degree. Now this figure, you see, this figure will have, see, this is not having line of symmetry, but it has got rotational symmetry. This is having so stick sign is not having any line of symmetry, but it has got rotational symmetry. Could you understand? Order 4. Whereas this N has got N also similar like this, no line of symmetry. Even it has, but it has got a rotational symmetry. This figure, you see, it has got a line of symmetry. See, circle, within the circle there is a triangle here. It has got one line of symmetry, but you can't rotate it to get symmetrical position. So it will not have any rotational symmetry. I hope you have understood. Now I will solve some of the sums from your exercise 5. I will talk to you. First question I will take. Which of the following statements are true? Fine. A rectangle has got 4 lines of symmetry. Is it true? A rectangle. See the rectangle. Rectangle will have 4 lines of symmetry. It will have 2 lines of symmetry, isn't it? Now, so it is false, so it will not be. A square has got 4 lines of symmetry. Yes, the square has got 4 lines of symmetry. Just see. If it is a square, then it will have 4 lines of symmetry. One vertical, another horizontal, then 2 diagonals, isn't it? So it will have 4 lines of symmetry. Now that's true statement. Scaling triangle has got no line of symmetry. You know that scaling triangle. If it is a scaling triangle, no line of symmetry can be drawn. Isosceles triangle has got 3 lines of symmetry. Again false. Isosceles triangle, 2 sides equal. How many lines of symmetry will have? Only 1 line of symmetry will have. This is one axis of symmetry. Okay. Now equilateral triangle has got 3 lines of symmetry. Take the case of equilateral triangle. All 3 sides are equal. If it is, then we have 3. That is a true statement. Through the vertices to the opposite side midpoint. And that is true statement. So you got 3 true statement so far. That is 2, 3, and 5. Now 6th one, a letter A has got 1 line of symmetry. Yes, letter A. You see, 1 line of symmetry it will have. Yeah, it will have 1 line of symmetry, isn't it? Now that's true statement again. 6th one. 7th one, letter D has got 2 lines of symmetry. D has got 2 lines of symmetry. No, D will not have 2 lines of symmetry. It will have only 1 line of symmetry. You understand? So that's not true. Then moving on to 8, letter M has got 2 lines of symmetry. Letter M, will it have 2 lines of symmetry? It will have only 1 line of symmetry. Got it? Now that is not also not true. Circle has got infinite axis of symmetry. Yes, it is. It's true that I have said to you. So many line of symmetry can be drawn on circle. So that's true statement. Now a rhombus has got no line of symmetry. Rhombus will not have line of symmetry. Two line of symmetry it will have. So it's a false statement. Now the last one, a regular polygon of n side have the rotational symmetry order n that I said to you. N side, 5 side, it will have rotational symmetry 5. A regular hexagon will have 6 rotational symmetry. You will give 6 terms and each minimum angle will be what? 360 divided by 6. That is 60 degree. Okay, that you understood. Now I will talk to you about question number 2. Which of the letter in English alphabet that I said to you, you can solve from here. Which of the letter? Question number 2 is said to you. Question number 2 is said to you that which of the letters have got one axis of symmetry. You know what are the letter will be? A will have one axis of symmetry. B will have one axis of symmetry. C will have one axis of symmetry. Actually C is like that only. D will have one line of symmetry. E also will have line of symmetry. Then what else? It will be, K will have one line of symmetry. This N will have one line of symmetry this way. Then V will have one line of symmetry. Then Y will have one line of symmetry this way. And then what? T will have, U will have one line of symmetry. T will have one line of symmetry. This many letter I think so. W will have one line of symmetry. That many letter will have one line of symmetry. See, one this way, this way, this way, this way, this way. Now this way, this way, this way, this way, here and here. This many letter will have one line of symmetry. Okay. Now that is the answer. Then two axes of symmetry. Which are letter? I said to you, two axes of symmetry. H will have two like axes of symmetry this way and this way. I will have two axes of symmetry this way and this way. Okay. Now X will have two lines of symmetry this way and this way. Am I correct? Now three axes of symmetry. Three axes of symmetry. English letter. No English letter. None. We have three axes of symmetry. And then fourth one will be how many? 4 or more letter O can be. But letter O actually if you are writing little oval like shape, if you are writing letter O like similar like a little oval shape, actually letter O will have two lines of symmetry like this. But in your book it is given letter O like circle, so it will have infinite line of symmetry, more than 4 lines of symmetry. Got it? Okay, we'll discuss rest all